Earthquakes and tropical cyclones, also known as hurricanes, are the world's most dangerous natural hazards. Yet, our current forecast models often fail to accurately predict these events, resulting in significant loss of life and damage. More specifically, from 1980 to 2023, the United States experienced $62 billion tropical cyclone events, resulting in a total of $1.4 trillion in damages and 6,897 fatalities, which translates to an average of 1.4 events, $31.3 billion in damages, and 157 lives lost per year. Regarding earthquakes, the deadliest earthquake was the magnitude 7.9 San Francisco earthquake in 1906, which claimed over 3,000 lives. Meanwhile, the costliest seismic event was the magnitude 6.7 Northridge earthquake in 1994, with damages estimated at $40.5 billion, adjusted to 2023 dollars. Hi, my name is Serena Cheung, a program analyst in the National Preparedness Division at FEMA Region 9 in Oakland, California. I am part of the CHDS cohort 2205-2206 March 2024 graduating class. Imagine you're preparing for the upcoming hurricane season on the East Coast of the United States, and a few months before hurricane season, you start to receive reports of birds breeding and migrating earlier than normal, and other atypical behaviors. Then months later, you receive reports of sharks escaping to deeper waters, and then a week later, oceanic fish similarly fleeing to deeper waters and exhibiting a significant increase in nighttime movement when they are normally less active. Individually, these anomalous animal behaviors may be explained by various environmental factors, but when you look at them collectively, you start to see a pattern. Meanwhile, on the other side of the country, say right here in California, imagine snakes that are cold-blooded, meaning they regulate their temperature by their environment, start emerging from their winter hibernation earlier than normal, and caged snakes start crashing into walls. Then a week later, you receive reports of dairy cow milk yields significantly dropping. Then mice markedly decrease their activity and have undetectable circadian rhythms. Then various farm animals such as cows, dogs, and sheep significantly increase their movement and activity levels. Then all of a sudden, ants that have very predictable routines have an observable decrease in their nighttime resting and daily activity levels. What I'm describing is just a sampling of discernible changes in animal behavior, what I refer to as adaptive animal behavior in my thesis, which describes these intriguing shifts in animal behavior in response to pre-disaster environmental cues. What I discovered in my research were three main findings. First, various avian, terrestrial, and aquatic animals, as I just described, exhibit noticeable behavioral changes before tropical cyclones and earthquakes. Second, these adaptive animal behaviors have the potential to be diagnostic precursors that may indicate the location, time, and severity of these natural hazards, three key aspects of disaster forecasting. Third, the existing evidence is robust enough to warrant a more systematic investigation to confirm that animals can be used as bioindicators, signaling environmental changes and impending tropical cyclones and earthquakes. Why is this research important? Because collectively, these animal-based indicators have the potential to improve disaster preparedness as well as the accuracy of forecasting across different lead times and locations. Amidst the growing unpredictability and severity of natural disasters, exacerbated by the effects of climate change, unearthing innovative ways to advance forecasting has become a critical priority for safeguarding this nation. As Leonardo da Vinci is quoted saying, "Learn from nature, that is where our future lies." To address this homeland security concern, we should look to nature for inspiration and continue exploring how adaptive animal behavior could serve as the contemporary equivalent of a canary in the coal mine, conspicuously sounding the alarm for the onset of natural disasters through their instinctual biological responses.